Hi everyone, I'm Judika Edoutin. I'm Deputy Director of the BIM program at SNCF Réseau, and I'm delighted to present you with my colleague Quentin Marquet. Um, this experimentation, which is about BIM and GIS technology using for a railway maintenance perspective. So um, just before starting, a few words about SNCF Réseau. SNCF Réseau is the main infrastructure manager in France, and SNCF Réseau is about 30,000 of kilometers of rail and 5 million passengers per day. SNCF Réseau is also invests on this network each year about 6 billion euros. So this investment is managed and is generate about 1,600 work sites each year in France. So is this modernization is one of the major activities of SNCF Réseau to keep the network and operational. So um, in the perspective of modernization of the network management, SNCF Réseau launched a very ambitious program, which is organized in 3 phases. The first one is about a development of BIM skills, and where we are to manage the maturity of BIM, to prepare tool, to prepare stakeholder commitment, and so on. So this step is progress now, and we also start the second phase, which is about the generalization of BIM, industrialization of BIM process across the whole project management issue. So this is the step we are now. And the last phase is about end-to-end digitalization. And we are expected the first real use case in railway contests at SNCF Réseau is expected about 2023 and 2024. So the project we presented you here is about benchmarking tool and in perspective to create added value use case for BIM, uses BIM specifically on maintenance issue. And for that, the contest is in the south of France. It's about 30 kilometers of track where there are some maintenance to have to evaluate really the added value using BIM in maintenance contests. So this work and this experiment start with using and integrating data coming from the existing database, existing 2D plans and GIS database, and to manage that in order to create a BIM model to support the experiment. And we also have the point cloud information coming from LiDAR and reality capture, which SNCF have 360 camera to do that. And we also use technical information about track, which is in 2D in traditional way. And the first step of this work consists to have the model authoring using mainly Autodesk tools, Civil 3D, InfraRox, and Inventor to create track alignment using point cloud, but also using technical information on corridors, and to position the track on that. And the second step is about managing maintenance information to manage really what is the maintenance issue and topics, For example, we have to prepare and to organize the defects, which are the main issue to planning track maintenance, and to have a representation of that, the different kind of defect, linear defect, but also punctual one. The punctual defect is about track defects, but also turnout defects, which are in existing database. We have to prepare physical representation on the BIM model that is related on this defect, which is not visual. So we have to create a visual object to position each defect and to link them to the existing database. So by the end, we have a step of integration of all this information in the BIM model that we create, and using Dynamo scripting specifically to connect this object and this defect position on the BIM model to the existing database, and to be able to assess by clicking on each defect position, like the tag, 3D tag, to access all information related to this information. And this integration was done. We have also we do the request on this database to reorganize the information inside each model, and we use different platform to address interoperability issue, to be sure that the information we create using different tools can be available for the operational people on the field. And for that, we test the capability of ArcGIS platform, but also Trimble Connect infrastructure. So at the end, the great added value of this experimentation was to demonstrate that we can, in BIM model, bring information on maintenance in the context of the real context, and using the capability of the end mobile device, such as mixed reality device, put this information on the field to use that directly by the operational people who need this information on the field. So the great result of that is that we demonstrate that organizing the database, we are able to create and to bring information from the BIM model to the field, to the people who need that, and to be able, for example, to identify in visual way the next, for example, plane maintenance operation, for example. That is really useful for the maintenance people. So, as you can imagine, we do not. This work was not done in the very natural and fluid way, specifically from interoperability point of view, because we use many tools, and as you can imagine, the transfer of information from one tool to another is not really issue. And in the second part of this presentation, my colleague Quentin will present you the different challenges we need to overcome to be able to generalize this kind of process for all railway sectors. So thank you for your attention, and I let Quentin to present the next part of this presentation. Thank you, and Quentin, floor is yours. Thank you.
Hi Jdkel, many thanks for your presentation. I'm Quentin, a BIM and GIS consultant subcontracted by SNCF Réseau. In this chapter, we will talk more deeply about software and data flow information. For the first experimentation about maintenance model authoring, we used Dynamo visual programming to link external alphanumeric data to 3D solid coming from corridor in Autodesk Civil 3D. This workflow was admissible for rail or ballast areas, but we discovered some deficiencies about slippers implementation. we had objects, massive rehearsal, and maybe it will be smarter in the future to use a GIS approach with 3D symbology. In fact, whatever could be the physical representation of a sleeper, timber, concrete, or by-block sleeper, it would be preferable to use only points and change stylization on the fly. Moreover, to use Dynamo, we had to use IT robots programmed to extract and so duplicate information from internal data lakes. Still, with a GIS approach, we can expect to complete a better job in the future by a direct connection on urbanized data with our new Trimble Quadri and Connect command data environment. Connectors are the key to the success. The project was completed in 2 phases. Phase A, experimentation on 1 kilometer length. The IFC export is about 184 megabytes without the terrain. For the phase B, it was the full maintenance area described previously by JDKL. For 30 kilometers, we have 2.5 gigabytes IFC still without the terrain. The last one was too big to be created in only one part, so we had to split it in 3 areas. As you can see, with the files wave, BIM models are not the best solution to support the full tracks managed by an infrastructure owner such as SNCF. Initial IFC file for a 30 km maintenance area was so important that some SaaS platforms were not able to read it. Here, for example, the Mesoteam Common Data Environment from Prozis. It required to split in several small-length areas to open it on the cloud, still without the existing ground. So that was not possible to have our terrain with IFC due to an important linear and numerous tracked internals. We decided to start experimentation about CTGML format. CTGML is an open standard issued by OGC. About it, please look about their new logo. We had several levels of detail representation and are very different that we can have for BIM model and new ISO 19650 definition. To start writing CTGML, we reused former investigation about FME middleware and former scripting. With VRMS distributor in France, we were able to recreate geometry coming from GIS data tables by fixing a solid tree construction upstream. Thanks again to this team to inspire us and complete our first step alone with FME Workbench. Moreover, to identify the main useful transformers allowing to write or transform CTGML, we had access to several samples coming from safe software. Do not forget that this technology is the only way to bring back files to AutoCAD, to Autodesk Map3D, InfraWorks, or Esri ArcGIS ecosystem. The first step was to write CTGML directly from a native model authoring file format. We discovered just how to complete scripting, and we didn't try to optimize the features in correct classes. We just used generic CT object. We had a surprise for the 22 GB wave due to sleepers representation. For the future, we will for sure investigate 3D symbology for sleepers. Unfortunately, very few viewers can read directly CTGML, especially in 3D. Some of them can only open in 2D, such as QGIS. CTGML is a complex data model and requires very large files. Each of them can be directly edited by a simple notepad. About geometry, CTGML uses only boundary representation, named BREP, and cannot use the CSG or sweep path representation. The second step was to write CityGML with simple feature, no longer as a generic city object. Randomly, we choose what sounds the most similar object without integrate the potential links between several CityGML features or parts. After all, when you are discovering CityGML classification with an ETL tool, all features are listed by alphanumeric order. A transformer dedicated to appearance allows us to keep different colors, and we discovered that FBIM software from CSTB can load several GML files and aggregate it without the requirement to have all placed in the same file. 55 features are standardized in CityGML format. Each of it has its own requirement related to level of detail 1 to 4, following also the kind of geometry, solid, multi-surface, multi-curves, and so on, and feature roles. It is more complex than we thought to find the correct combination and succeed to write CityGML files. After completing the first script dedicated to simple features, we started our investigation about advanced design, especially about bridge and tunnels. The process is still ongoing. The job is very different due to the assembly of features for a bridge. You can see the UML diagram on the right, and you will have to manage bridge construction element, bridge furnitures, bridge parts, bridge installation, and bridge rooms. There are numerous sub-features. Of course, you will have also a similar definition for tunnels. Don't forget, whatever you are working for bridge or tunnels, that the structure is based on a road, so a transportation part, also linked to the terrain. Semantic and topology representation must be taken in consideration. Until now, we just worked about translation of native files to CityGML format. The next goal is to be able to convert directly IFC files to CityGML. On the screen, we already have experiences to write it with an ETL tool, but we still need to investigate how to transcribe IFC classes in BREP and keep alphanumeric data with attribute mapping. Cherry on the cake, FME Workbench has transformers allowing to bring back to the geographic context some design produced by non-linear tools such as Autodesk Revit. We didn't start again to have a look about it, but it will be a future challenge. So, once again, thank you for your presence and for looking this movie. Whatever where you are coming, please enjoy your trip in Lyon in January 2022. Thanks.